Hello, everyone. Thanks for coming. Do you hear me well? Okay. So, yeah, this talk. I will share our stack migration experience from both infrastructure to devs and as well as an organization standpoint. So I will share about the motivations behind our Kubernetes stack change, the experience we gained into building our own bare metal cluster, and how we made it so that it was adopted by every kind of text that we have at Numberly. So I will be sharing some configuration examples. I will also take this chance to showcase our GraphQL choices that we use for building APIs. So it's not a talk on GraphQL itself, but rather about the choices. I will share also examples and code examples to showcase the demo app. And then I will demonstrate how they fit together. So that will be about the developer workflow. So it is. Just a quickie about myself. You can find me about everywhere as Ultrabug. I'm a Gentoo Linux developer. That's my open source life. I maintain quite a number of packages, and the MongoDB one, for instance. I'm a PSF contributing member because I open source some code and work on some Python code, and I'm also CTO at Numberly. Before we begin, I wanted to share the story that when I submitted this talk, a colleague of mine came to me and asked me this question. He came here and said, "Hey, Alexy, couldn't you have more buzzwords in your talk title?" And so I felt obliged to answer these questions, since you may also have wondered about it before you decide to come here or not. And the answer is no. So let's begin. The first thing I wanted to share is our previous workflow that has been up and running for more than 5 years at Numberly. So this is how we still are working for some part of our projects, but this talk is about this transition and how it's being done. So we have our friendly developers. We use GitLab internally. So that's where we basically have code repositories, configuration repositories. We keep them separate, so there is no secrets in the code, in the source code that we have. And that's where we run continuous integration, code reviews, etc., etc. So that's basically what the developers are interactive, and the project managers also are interacting with every day. Then to start the deployment and the orchestration of the deployment of the projects that we built into GitLab, we base ourselves. The developers just have to create a YAML configuration file at the source, at the root of their repository, and it's basically an Ansible task-compatible YAML. Then we created a web interface that we call DeployDocus that is basically linked to GitLab. So you log in into it, and that's proxying the GitLab SSO. And then you can see the list of the projects that you work on. And then you can start selecting it and then executing it, executing an Ansible playbook that will run in the background. That will basically connect to GitLab, get the source code repositories, merge them together. And so it's Ansible based, and then it will connect to all the bare metal servers that we have, at least the ones that are targeted and configured in the YAML configuration file beforehand. And it will start creating virtual environments, so virtual lamps, Python virtual lamps, and take the code, deploy it inside, and then start configuring and deploying a USG configuration file, configuring Nginx ingress configuration files, and everything at once on multiple servers for clusters. If the project or service that we are deploying is a public accessible one, we will need the help of some network engineers to set up F5 load balancers, which will also act as SSL offloading proxies, let's say. So all the SSL will happen in the F5 usually. This is pretty cool. It's working very well, and it's been working very well for a long time for us, but there are still some limitations in it. Well, the first obvious ones relate to the deploy docus web interface and to the Ansible playbook that is running everything behind. If GitLab is changing their API for some reason, we have to fix it on all those orchestration environments in Ansible and in deploy docus. So it's a bit of work. It's not happening that often, to be honest, but it happens. And when it happens, you basically end up with a large herd of angry developers that can't deploy their things anymore. So it's not that cool. On the server side, the virtual lamps that we are able to create on the bare metal servers depend on the Python versions available on those servers. So that means that we have some operation, maintenance to keep up, to update, et cetera, every bare metal server that are part of the different web clusters or application clusters that we operate. And of course, we also depend, and the developers also depend on the network engineering team to do this mainly manual, not fully, but mainly manual SSL configuration when the website has to be public, or the API, or whatever it is that we need to be accessible on the web through an HTTPS URL. Also, you can see that it's based on virtual environments, Python ones mainly. So what if the developer needed a different kind of stack? That would mean that the ops or DevOps people would have to modify as well or deploy it on, make it available on the bare metal servers. So, and there is no uninstall feature as well. So this is something that we wanted to have for some kind of corner case problems, but it's not that important, but still, there is no, hey, just forget about it and install it. There is no performance isolation as well, no very strict one at least. So you can have some problems sometimes when a developer deploys a code that is killing the RAM of the node. So we could have just kept this and rewrote a bit to the orchestration. You could ask yourself, but okay, but why don't you take all this Nginx, ubusgi, and virtualenv stack on the servers and just run them on LXC or Docker or Rocket, and you would be addressing basically what's on every node. That's right, but that means that we would still have to keep up with all the orchestration that makes this happen. So it's solving a part of the problem. And when we started that, when we felt that it was starting to be the right time to move on, actually the Kubernetes ecosystem was already something that was, I won't say stable. I would say popular enough so that the community behind it and some kind of documentation was enough for us to go into it. So we didn't want to have to maintain this orchestration, container orchestration, and things like this by ourselves. We just joined in the fun and decided that we would be building with those bare metal approach our own Kubernetes cluster. So that's what we did, and I'm now gonna give you some overview of how we've done it. The first thing was to actually build the bare cluster, so that's the methodology. Then we had to decide on the tooling, and when I say tooling, it's mainly how will the developers interact with the cluster, which is not a simple question. actually. So you will have to take a stance on the level of abstraction that you want to give. We wrote documentation, because if it's not documented, it doesn't exist. And then we worked hard into making sure that this new platform, this new way, was both adopted and supported. So there are ways, organizational ways to do this, and I will share a bit later how we did it. And then we distributed the expertise so that the expertise on the Kubernetes workflow and cluster is not the thing of only the people that build it in the first place. So a lot of our production clusters at Numberly run on Gentoo Linux. This is part of our deep dive approach on everything we do. So we decided to continue on this, and it's also a good chance for us to get to know and to understand all the bricks, and there are numerous in the Kubernetes ecosystem, how they fit together. So we built it on Gentoo. We leverage on our infra as code technology, not technology, but infra as code way of approaching things. And so we have already a lot of Ansible playbooks that operate all those machines that I was talking about earlier. So we will leverage on it and just added the fully automation on deploying, reconfiguring, and provisioning machines on the Kubernetes cluster. As our name says, we are obsessed with metrics and numbers. So we are extensive users of Grafana, and whether it comes from Graphite behind or Prometheus. So we built dashboards to monitor and see how the cluster was going on in the early stages. Then we decided to adopt a developer-driven approach when designing our cluster, because we wanted to remove friction. So that was our main goal in the first place. Of course, that means that it doesn't have to compromise security as well. So we will see how and the decision that we made to keep a right balance. But one thing we adopted quite early was we didn't want to have too many abstractions. So actually, we decided to allow developers to interact with the Kubernetes cluster directly. So they have kubectl at their disposal. So there's no Helm or no overlay between the developer and the Kubernetes cluster. So that means that we also took some security measures to make sure that it didn't get out of hand. The first one is that at Numberly, we are using the Google Suite. So that means that every employee has a Google account. And this Google account offers an OpenID authentication. So the workflow to first authenticate on the Kubernetes cluster is to just go to a kubectl URL and then log in as usual using the Google Suite account that they have. We get a free MFA, second factor, thanks to the Google account. And every developer and employee at Numberly has a YubiKey for this. Then it provides them through the Gangway project their kubectl that they just have to download, and they're up to start interacting directly with the Kubernetes cluster. Then we have to handle authorization and permissions, and for this we already had a nice workflow on GitLab. So we have everyone on GitLab and groups on GitLab and roles on GitLab. So we decided that it might be interesting to map all those permissions and groups to Kubernetes. And there was no project that was doing this, so we decided to open source our own, and it's called GitLab to RBAC. So the principle is that a namespace in Kubernetes relates to a team, and this team relates to a group in GitLab. So that's how it was already working. And this project will just continuously map the GitLab namespace and groups and users and their permissions to Kubernetes. So then we don't have two separate authorization and permission systems to operate. We just do everything on GitLab, and it replicates to Kubernetes. So to give you an overview of the cluster capability and choices that we made, GitLab also offers an image registry that we, of course, leverage. So that's where the images are downloaded when they are deployed on Kubernetes. We enforce some QA on this, security QA. Only whitelisted images can be deployed, but we don't want any random image on the web running on the Kubernetes cluster. We enforce from the start the run as known root. That means that no container can run on Kubernetes if it's running as root. And we have strict network policies, so that's netpol policies that regulates how pods can discuss between themselves and or developers to pods or internet to pods. Basically, we disallow almost everything unless it's coming from the ingress. Speaking of ingress, we are using the Kubernetes ecosystem provided Nginx ingress, and we added the fully automated Let's Encrypt certificate lifecycle. So this also offers the developers to just with two or three lines that we'll see later of configuration to have a free HTTPS endpoint. The multi-tenant cluster means that we decided for a start, maybe it will change over time, to have all the environments inside the same cluster. So we don't have a Kubernetes cluster for development, a Kubernetes cluster for staging, the Kubernetes cluster for production. It's a multi-tenant one for all environments, so that means that you can have a production pod running next to a development one. There's no real consensus in the Kubernetes ecosystem yet about this strategy. Our approach was we are rolling out something, so we want to leverage on the resilience and the simplicity of the machines and the workflow that we will provide. To help people get acquaintance with the cluster, we also created a special sandbox namespace that basically allows anyone that is authenticated to do anything. And it's wiped every day. You don't have to read this. I just put it in for reference on the slide so that you can see how we wipe it every day. So just to test. We don't have a distributed persistent storage yet. That doesn't mean that we don't provide persistent storage, but it's a simple one through NFS. So it's really mainly for now about stateless machines, stateless applications. So we won't be hosting databases on Kubernetes yet. Maybe it will come, I don't know. And then when you are a bit obsessed about security, there is a good benchmarks provided by the CIS. And so we, of course, made sure that our cluster passed it. Then you have to write a good documentation. So I'm providing here the topics that we felt and was working to get it covered. So when you enter this space, all your text might not know what a Docker file is, so you need to kickstart them in Docker, you need to kickstart them in Kubernetes, you need to kickstart them in the deployment as well, etc. So we have leveled this a bit. The idea behind this and the trap that I hope we didn't fall into is not to rewrite the Docker documentation or the Kubernetes documentation. Instead, this documentation is a practical one, making references if needed, but it's a practical one. So it's get your hands into it and let's go, step by step. And it's really helping, and it has been very helpful for our developers to get their hands very quickly in the Kubernetes cluster and have concrete results. And here, the sandbox namespace helps a lot because they can try and learn in it. And everything that we ask the guys to test is based on the sandbox namespace. So this is why we are building built this. We put a lot of effort in this actually, because this is where lies your adoption. Speaking of adoption, we have to foster it, and then you have to scale it. At Numberly, we have multiple teams on multiple poles. They share the same core attributes. Let's say backend developers, but you have multiple backend developers, for instance. So in all those teams, we wanted to make sure that there was someone that was identified and valued as well as being able to help and give support, so that not only the people that build the cluster were the main reference and were starting to get spammed, so it was not it's not scaling that way. So we created our internal Kubernetes certification, and so that the people that take this certification, we can make sure that they have the basic but still strong knowledge, enough at least, to make sure that they support the people around them. And this is also a nice way, I think, to value the expertise of members of the teams. So a quick takeaway on the Kubernetes side. So GitLab, we use GitLab for Airbag, image registry, and with Kubernetes, it's called GitLab to Airbag. You can check it online if it's useful to you. We'd be very happy. It's written in Python. We have always to balance security versus freedom. They are not opposed at all times, but still that's something you have to take into account. Give freedom, but not so much that it can put your company at risk. That's why we have to enforce the security and QA rules from the start. It's important for us, and I guess for anyone starting in this path. For now, we get reports on not whitelisted image running. We have to do to make it enforceable from the start as well. What I like very much and what we value very much in this approach is that now ops can concentrate on adding features to the cluster that developers can leverage on their day-to-day work. And I think that this is really nice. So instead of being cluster by cluster, now you can see, and we can see our Kubernetes cluster as a set of features that we can use. Having practical and documentation helps a lot. And to spread expertise, maybe a certification is a good trick. Maybe we will create more certification levels later. So how does it look now? It basically looks like this. We removed the configuration repositories. Now it's moved to Kubernetes secrets and to vaults, depending on some projects. We are not finally stable entirely on this, so that's something that we're still working on. User roles, they are mapped to Kubernetes or RBAC. The groups to namespace, that's where the Docker image registry is. And now, instead of having the interface at the bottom, we just allow our developers to run kubectl commands to interact with the cluster, which will in turn orchestrate the pods with an ingress nginx. We have a free Let's Encrypt endpoint for the projects that we need, and we still need to work on automating the F5 SSL offloading as well for the public domains. We deploy a lot of projects every day, so you might wonder, why don't you just go for Let's Encrypt and keep on this F5 thing, right? It's because we have to face some limitations from our clients, and that forces us to support, let's say, not so up-to-date browsers. So yeah, so we have to be able to be in between. That's especially true when you work for banks. Anyway, so now let's try to build a GraphQL application on this Kubernetes cluster, and then we'll finish with what's the workflow that makes it happen. So the demo app that I'm taking, and that the source code that is provided as well. I thought it would be a nice introduction or idea to demo how you can proxy, let's say, the Trello REST API through a GraphQL endpoint. So you interact issuing GraphQL queries that will be turned into Trello API REST queries. The first thing you ask in here is, how do I do GraphQL in Python? Usually, the answer is Graphene, which is the most popular library to do GraphQL in Python. At the time that we were asking ourselves this question, they were not supporting async I/O, and we are very async I/O lovers, so it was kind of a problem. The other problem was the design approach of Graphene, where you basically explain your GraphQL schema as code, or as classes, etc. So this is how you express it. But in the GraphQL ecosystem, as we will see later, there are other ways, and most importantly, language agnostic ways to do it. So that's why we didn't go for Graphene. Instead, we went for this. So for the non-French guys around here, this is called a tartiflette. It's a mountain dish, let's say. It's basically potatoes, cheese, cream, potatoes with cheese, with cream, with potatoes and cheese, and a bit more cheese. You have to finish. The top must be cheese. Okay, reblochon. Anyway, and if you are very hungry, you can add larder in it, but that's a plus. So the project itself is called tartiflette. It's meant, so basically you understand that the core developers are French. They are the guys at Dailymotion. They're doing a great work. And what I like, especially in tartiflette, is that it's modern Python, let's say. It's fully built on async I/O, and a good way, I think. And it has a schema-first design in the schema definition language design. What this means is that you will express your schema using the GraphQL SDL only. So this is completely agnostic to the language, and then you will just point the tartiflette engine to load this raw flat file, and it will load the entire schema. So you don't have to express it using code and classes or Python objects. You just express it in a way that everyone in the GraphQL ecosystem can understand it. And then you put it in the engine, and you're good to go. And we'll see how. They offer an AO HTTP integration. They embed a GraphQL development web interface to help you as well. And so it's pretty developer friendly. Tastes very good. This is what the SDL looks like. So you define a query, and then you will basically define types. So here I'm defining the type member, which refers to the member type in the REST Trello API. That is either you or someone in Trello. And then you have your properties and scalar associated to it. Okay? So this is not Python. This is not any kind of language. This is the SDL, the standard SDL that defines schemas in GraphQL, and that can be understood by any kind of language or library. What's interesting as well is if you look at the Trello API documentation, you see that the member object will have a property that is listing the ID of the boards. That means that when you query a member, you will get the IDs of the boards and not the details of the boards themselves. So when you operate the REST Trello API, you have to get the member, get the list of IDs of the boards, and then for each board, if you just wanted to display the name, you would have to make a single query with the ID to the board's endpoint and then get the name out of it, right? This is how you would do it in REST. GraphQL allows you to abstract this because this is graph theory behind it. So you will have only to add a board's edge that will be a list of board objects. So this is how you will present it to your in your GraphQL endpoint. And then the machinery or the magic that you have to do is to abstract this and make sure that your your GraphQL endpoint does all those REST calls for you. But for the front end or the initial query, you will have one query that will end up in being 3 queries to the RESTful APIs. So that's one of the key features, let's say, of GraphQL. But you can see it in here. So it's explained. Show me some code now. How do you create this? You have the generic SDL, so it's in the middle. You create the engine, and you pass it the path to the file, to the SDL file, raw file that is on your project, and that's all. And then it gets validated, etc. And then your engine is ready to get queries, basically. So when you then issue a query to a type inside your GraphQL schema, it will need to know some resolvers that are able to resolve to get the data that we are asking for. So that's what the import of resolver is about. And to write resolvers in tartiflette is just a simple decorator pointing to the node that we are talking about in the schema. So if we remember the query and we have the type member, you will just have to create your async def, a simple async function, and decorate it with the resolver, and that's all. You will return a dict object that will represent that will have properties, and if in those properties they represent an edge, then the engine will for you look for, hey, do I have a resolver for the board's edge? Because for now I just have the IDs, and I need to go and look for those IDs. I need the names, but they were not provided on the first call. It orchestrates everything, exactly. So it will iterate like this through the graph based on what got queried, and then just call the resolvers functions like this. Simple, super easy. It will do it concurrently as well, so it's also quite fast, and it's really easy to reason with. So here you see that I get my boards from the ID board that got returned in the JSON from Trello, and then I just have to loop for each ID board and get the name, and then I will just return the object that is that has been returned by Trello. I didn't have to filter as well, because the filtering is already done by the GraphQL engine as well. So that's all. Root query resolver, and then edge resolver. OK, now let's ship it. So the first thing you have to do is a Docker file. This is a demonstration of a multi-stage build to get a smaller image at runtime. So I find it very, very helpful. So I'm providing this for you to come back to it. As you can see on line 25, you also have to enforce the nobody user as running your application. And that's basically how it's built. Then the workflow itself on the Git side, we will have the build, and the build will relate to the current Git branch. So I provide the simple script just to showcase how you can do it in a hook, how to build and deploy the image to your GitLab registry based on the current branch you're working on. So development branch will be development instance or pod on Kubernetes. Staging branch will get you a staging pod in Kubernetes. For production, it's on master plus git tag. So it's a bit more complicated than just the bash here, but it's how we do it easily. Now you have to deploy it to Kubernetes. For this, you create a deployment YAML. I trimmed it a bit because they are quite verbose. You can see that we also enforce in the deployment the run as nobody. And then we get the secrets, and we provide them from the Kubernetes secrets, and we provide them to the code as environment variables. So that's how it's done. And on the developer side as well, you can ask to get your Let's Encrypt SSL endpoint with the domain that you want, and it will create it for you for free. So I'm crazy enough to have a quick demo. Yeah. with my HHKB keyboard. So you ready? Okay, let's go. So basically, you type 3. I can do it without my hands. And you just build and upload this. So this will build the thing and upload it to GitLab. And then you can see that for now it's not running. So there's no deployment for our project. So then we will apply the development deployment. So here you can see that it's being created on Kubernetes. Now it's there, but it's not ready yet, 0 on 1. So let's see if there is a service. Yes, we have an IP for our service. Is the pod created? Not yet. Now it's created, it's running, and now it's ready. That's all, and I have my SSL as well. Takeaway on GraphQL, it removes friction, it helps teams collaborate because this gives you a spec, and so it normalizes how data is addressed and communicated between teams. Having a SDL approach, I think less people concentrate on the data. It's really important and not the code. Tartiflette is really modern and has this SDL approach, and it's very good, I think. So give it a try. We have a workflow for our environment deployment, get on Git branches. Maybe we will challenge the multi-tenancy of the cluster later, as I told you before, and it will maybe have an impact on this. The secrets are shared to applications as environment variables, and we still have to work on generalizing vaults. And giving power to the developers, we decided to give them the kubectl as their main tool to interact with the cluster. So maybe at some point when the adoption grows, we will add and allow some other abstractions to interact with it, just as Helm. But for now, it's working on pretty well. And that's it. You have all the source code in here. You can reach me out here, and I think we still have some time for questions. Thank you very much.
If anyone has a question for Alexys, please come to the microphones in the aisles.
Thank you for the presentation, and I wanted to ask why you decided on using bare metal instead of using either cloud provider for the service and then Kubernetes on your own, or using fully Kubernetes as a service?
Because most of our applications interact with data, and this data is on our own infrastructure. So we have a hybrid approach with cloud. We're not fully cloud-based. We come from the bare metal approach. And this is something that, first, we value very much because we value the skills of the people that work with us, and that's our own machines, own skills. It's also something that we have to cope with because it requires some extra work, of course. But mostly because all the data that lies behind it is also hosted on our machines.
Okay, thank you.
I really liked your documentation page. That was really great. Do you use some tools to deploy the YAML files, or are you just use the kubectl like you showed there?
kubectl.
But like if you have to, because you have dev, staging, and in prod, like 3 environments, so you create 3 YAML files for each services.
Exactly. Exactly.
Thank you.
Exactly.
Over here.
Hello.
I was wondering, when you have the Nginx, and do you actually host Nginx inside of each of the pods that runs Python as well?
No.
Oh,
we have a separate namespace for all the ingress because we apply network policies between the namespaces as well.
Okay. Thank you.
Hi, thanks for the talk. Since you are operating your own Kubernetes cluster, have you considered using OpenShift instead?
I don't think your mic is working, I'm afraid. I'm sorry. Can you? I didn't. Thank you.
Hi.
Hi.
Since you're operating your own Kubernetes cluster, have you considered using OpenShift instead?
No.
No. You haven't evaluated or benchmarked the one solution?
No, we didn't evaluate it. We have a quite deep deep dive approach, so we wanted to operate on Kubernetes, that's for sure, and then we wanted to operate it with no other things.
Because I think it's easier to install locally on your bare metal clusters.
Maybe, but I'm not sure this is provided in Gentoo Linux.
No, there are YAML scripts to install.
Yeah, but it doesn't fit with how we operate our own infrastructure today.
Mm-hmm.
So it just, for us, it's more natural to just go for the packages themselves and then
Okay.
go for every brick because we have all the Ansible toolset already at our disposal.
Okay, thank you for the answer.
You're welcome.
Thank you so much, Alexys. Let's have a hand for him.
Thank you.